You know that specific friction when you're navigating a web checkout, right? Your cart timer is counting down, you finally hit submit.
Oh, yeah, instead of the confirmation page, the whole screen just grays out on you.
Exactly. The screen grays out, and suddenly you are staring at this grid of like really grainy, low-resolution photos.
And you're asked to find the crosswalks.
Yes. In an instant, the smooth user experience just completely halts, and you are forced to, prove your own humanity to a server.
It's honestly a brilliant piece of technological interruption. I mean,
Yeah.
you are sitting there overanalyzing the edge of a bumper,
Oh, totally.
debating whether a 3-pixel sliver of a traffic light pole technically counts as the traffic light itself.
Which is so stressful.
Right. Because you are fully aware that if you guess wrong, your session might time out and you lose the tickets.
So the mission of our deep dive today is to pull back the curtain on that exact interaction. Because what feels like a minor, poorly designed annoyance to you is actually, it's the visible surface of a massive, evolving digital arms race.
It really is.
We are pulling our primary insights today from a piece on tech-reader.blog. It's by software engineer Aaron Rose, titled CAPTCHA in 3 minutes, alongside, some of our own research into the mechanics behind it all.
Which, by the way, is a really interesting sort of macro-level pivot for that blog.
Yeah, they usually go super deep into the weeds.
Right. Typically, TechReader caters to a highly technical audience.
Hmm.
Like, their recent pieces covered deploying localized large language models on an 8-gigabyte Raspberry Pi 5.
Right, or stripping down Linux distributions.
Exactly, for minimal overhead. But here, they are dissecting a universal web standard that we all deal with, CAPTCHA, which stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart.
Okay, let's unpack this, because to understand why we are forced to click on blurry buses, we have to establish the threat model first. Like, why inject this friction at all?
Well, the internet relies heavily on automated scripts.
Right. Search engine crawlers, indexing bots, uptime monitors, those are the functional, helpful utilities of the web.
Yeah, the good bots.
Yeah.
But this friction, the KPTCHA, is designed for the other side of that ecosystem, the malicious automation.
And when we talk about bots in this context, we aren't talking about, a physical robot sitting at a keyboard.
No. We are talking about headless browsers.
Yeah.
We're talking about automated Python scripts using tools like Selenium or Puppeteer, hitting application programming interfaces or APIs at massive scale.
Right. They aren't interacting with the graphical user interface the way you or I do on a screen.
Exactly. They bypass the visual render entirely and just send raw HTTP requests directly to the server.
So if a human can manually fill out a login form maybe once every 10 seconds.
An automated script can fire off 10,000 credential stuffing attempts in a single second.
Oh, wow.
Yeah. There's a difference between someone walking through a stadium turnstile and someone trying to exploit the stadium's architectural blueprints to magically teleport 10,000 people into the seats simultaneously.
That is a great way to put it. The volume is the existential threat to the server there.
Exactly. Whether it's a denial of service attack or massive inventory scraping for concert tickets or brute forcing passwords, these scripts are optimized for pure speed and scale.
So the web application needs a bottleneck.
It needs a bouncer at the door. It needs a mechanism to force the interaction back into the physical realm to demand a biological pace.
Which brings us to the history of that bottleneck, because if you've been navigating the web for a while, you remember that identifying crosswalks is a relatively new phenomenon.
Oh, for sure. The initial iteration of CAPTCHA was entirely text-based.
Right, you'd be shown a string of letters and numbers that had been heavily warped, stretched out, coughed out with random lines.
And the engineering logic behind that text distortion was actually solid for its era.
How so?
Well, early optical character recognition, or OCR, was highly rigid. It relied on clean bounding boxes, predictable typography, high contrast.
Okay.
So if you threw a squiggly line through a lowercase e, the edge detection algorithms of the early 2000s would completely fail to parse it. Just couldn't read it.
But the human brain is highly adapted to pattern recognition amidst visual noise. Like, we can look at a mangled, melted letter A and immediately know it's an A.
Right. We essentially possess biological OCR that is incredibly tolerant of distortion.
That's fascinating.
Yeah, and that biological advantage was the foundational premise of the early Turing test. But the introduction of those text puzzles created this fascinating unintended feedback loop.
Oh, the training data.
Yes. When millions of people around the world began solving those warped text puzzles every day, They weren't just proving they were human.
They were acting as an unpaid, massive-scale beta labeling workforce.
Exactly.
This is one of those historical tech facts that completely reframes how you look at the internet. Every time you successfully typed in those hard-to-read words, you were often translating scanned text that early computers couldn't read.
You were literally digitizing the archives of the New York Times.
Or translating old books for Google Books.
And in doing so, human users created the exact dataset required to train the next generation of machine learning models.
Wait, really?
Yeah, by feeding millions of labeled, highly distorted text examples into early neural networks, developers trained the algorithms to recognize those specific distortions.
So we essentially engineered our own obsolescence. We taught the AI how to beat the test.
We did. The neural networks eventually surpassed human capability at deciphering warped text.
That is wild.
So the premise of the text-based CAPTCHA was entirely broken, because the machines became better at it than the biological users. The defenders had to abandon typography and shift to a new medium.
Real-world imagery.
Exactly. Complex, noisy, real-world imagery.
So the arms race moves from distorted letters to the visual chaos of street-level photography. We start seeing grids of bicycles, fire hydrants, traffic lights.
Yep, the classic grid.
But I want to challenge the assumption of how this works, because when I am forced to pick out a bicycle hidden behind a tree in a low-resolution image, it feels like I'm taking a cognitive test. I feel like it's testing my intelligence.
I know the feeling.
But the source material makes a crucial distinction here about what the system is actually measuring.
Right. What's fascinating here is that the image grid is not a test of intelligence or even visual acuity.
Okay.
It is fundamentally a measure of computational cost.
Meaning the system is looking for a task that is biologically cheap, but computationally expensive.
Precisely the opposite of how a computer usually operates.
Right.
Like a script can calculate pi to 10,000 digits in a fraction of a second.
Yeah.
But if you asked an early 2010s algorithm to parse a two-dimensional grid of pixels and determine if the geometric shapes constituted a bus.
Oh, under varying lighting conditions and angles.
Exactly. The processing power required was immense. Convolutional neural networks had to analyze edges, textures, context.
Whereas for a human toddler, identifying a bus is instinctive.
Right. So for a bot network trying to spam 1 million requests, running heavy image recognition models on every single request becomes financially and computationally unviable.
It totally wrecks the economics of the bot attack. If the spammer has to pay for the massive GPU compute required to solve millions of image puzzles, the attack is no longer profitable.
Exactly.
But again, technology doesn't stagnate. Those image puzzles were sourced from Google Street View cars, right?
They were.
So just like we digitized books with the text puzzles, we spent the last decade training autonomous driving models by identifying stop signs and crosswalks.
And the inevitable result occurred.
The machines caught up again.
The machine learning models optimized for object detection caught up. Modern AI can segment an image and identify a bicycle or a crosswalk with near-perfect accuracy.
Often faster than a human can process the visual field, I'd bet.
Oh, absolutely. Faster and better.
Which means the visual puzzle, much like the text puzzle, is structurally compromised now.
Yep.
And that brings us to the evolution that feels almost paradoxically simple. You go to a login page, and there is no puzzle, there's no grid.
Just a box.
Just a single checkbox that says, I am human. If AI can solve complex, noisy image grids, how can clicking a simple, static HTML checkbox possibly provide any security?
Well, because the verification has nothing to do with the checkbox itself.
Okay.
The checkbox is merely a honeypot for behavioral data collection.
Here's where it gets really interesting, and frankly, it sounds a bit like the Voight-Kampff test from Blade Runner.
It really does.
The system isn't testing your ability to click a box, it's measuring the biological micro-quirks of how you approach the box.
Exactly. When you load that page, the CAPTCHA script injects JavaScript event listeners into the document object model, or DOM.
And what are those listeners doing?
It is actively logging the kinematics of your hardware interaction. It records the X and Y pixel coordinates of your cursor.
Wow.
It calculates the time deltas between those coordinates to map your acceleration and deceleration curves.
So it's looking for organic imperfection. Because if I move my mouse toward the box, my hand has, like, microscopic tremors. My trajectory arcs slightly. I might overshoot the target by a few pixels and subconsciously correct my path before clipping.
And that variance creates a statistical fingerprint of a biological organism.
Mm,
Contrast that with a basic automated script.
right.
A bot programmed to bypass a checkbox will mathematically calculate the exact center pixel of the target, adjust the cursor coordinates in a perfectly linear path, and execute a click event instantaneously.
It lacks the biological noise.
Exactly. The security system analyzes that pristine linear trajectory and immediately flags it as synthetic.
Because it knows no human hand operates with mathematical perfection.
Ever. And it also analyzes the broader context. Did you scroll the page before clicking? Did you tab through the input fields?
Right.
What is your browser's user agent string? Is your IP address associated with a known data center or a residential internet service provider?
Okay, but I have to push back on the architecture of this a little bit.
Yeah.
If the JavaScript is capable of silently gathering all of this rich behavioral telemetry in the background, my mouse movements, my browser footprint, my IP history, why introduce the user interface friction of the checkbox at all?
That's a great question.
Like, why not just analyze the data passively and let me log in?
If we connect this to the bigger picture, you need a deterministic endpoint to anchor the calculation.
Okay, what does that mean?
The click serves as a necessary focal point. By forcing you to execute a specific mechanical action, navigating to a distinct coordinate and triggering an event, the system can calculate the exact physics of your approach.
Oh, I see.
Without a defined target, your mouse movements are just random ambient noise on a page. The target forces the intent, and the intent reveals the biological mechanics.
That makes perfect sense. The click is the controlled variable that allows them to measure the kinetic variance. But this brings up a massive tension in the architecture of the modern web. If we have the capability to track micro-movements, calculate acceleration curves, and evaluate IT reputation, why are there still instances where bots get through?
Oh, it happens.
Alternatively, why do we sometimes still get stuck in endless loops of crosswalk images if the system is so advanced? Why not just turn the security algorithms to maximum strictness at all times?
That is the core dilemma of web security operations. It is the constant negotiation between security thresholds and the user experience. You are dealing with the concept of false positives.
Meaning blocking a legitimate human because their behavior looks slightly too synthetic?
Exactly.
Right.
If you tune the security algorithms to be absolutely draconian, analyzing every single cursor movement with zero tolerance for anomaly, you will definitely stop all the bots.
Right.
But you will also block a user who is using a trackpad they aren't used to, or someone utilizing accessibility software.
Or just a user with a slightly erratic internet connection, maybe. And, in the realm of e-commerce, a false positive isn't just an annoyance. It is measurable financial loss.
Huge financial loss.
If you run a massive online retailer and your CAPTCHA is too aggressive, legitimate customers will simply abandon their shopping carts. The friction becomes a literal barrier to revenue.
So the website operators dynamically adjust the risk threshold. Aaron Rose outlines this balancing act perfectly in the article.
Yeah, it's like a dial they can turn.
The service provider is constantly turning a dial. If they detect an active, aggressive, credential stuffing attack originating from a specific botnet, they will crank the security dial up.
And the algorithmic tolerance drops.
Yes. Suddenly everyone gets the hard puzzles, the multi-page image grids, because the server is in a defensive posture.
But during a major sales event where user conversion is the absolute priority, they might lower that threshold.
Exactly. They accept that a small percentage of automated inventory scraping bots will slip through, because the financial cost of irritating real customers is higher than the cost of the bot traffic.
It is a calculated real-time risk assessment. So the friction you experience is entirely dependent on where that dial is set at the exact millisecond your HTTP request hits the server.
That's exactly right.
So what does this all mean for the architecture of the web moving forward? We established that the bots have functionally defeated the text puzzles.
Long gone.
They have sophisticated object detection models that can defeat the image grids. And if we look at the advancements in artificial intelligence, the very models discussed elsewhere on TechReader, the computing power available to malicious actors is just scaling exponentially.
It really is.
Are we reaching the end of the puzzle paradigm altogether?
Oh, the industry is already moving past it.
Really?
The reliance on active friction, where a user is forced to stop and solve a challenge, is being deprecated. We are transitioning into an era of completely passive friction.
Okay, passive friction.
The system relies entirely on the invisible telemetry we discussed earlier, operating continuously in the background.
So moving from prove you can solve this puzzle to we are secretly analyzing how you exist on this page.
Exactly. The future iterations, commonly referred to as invisible CAPTCHA, don't require a checkbox at all.
Wow.
They utilize advanced canvas fingerprinting to analyze how your specific graphics card renders microscopic graphical
That
elements.
sounds intense.
They evaluate your interaction with the entire site over the duration of your session, generating a continuous risk score. If your score remains below the threat threshold, you never see a puzzle. You hit submit, and the backend authenticates the token silently.
The ultimate goal is zero user interface friction for the human while maintaining an impenetrable cryptographic wall for the automated script.
Exactly. The battleground has moved entirely out of the visual realm and into the data layer.
Which is the logical endpoint of this arms race, I suppose. As the cognitive tasks become trivial for AI, the only differentiator left is the complex, messy reality of human behavior and hardware variance.
The technology adapts, but the core objective filtering, the biological signal from the automated noise, remains identical to the days of warped text.
It completely alters how you perceive the mechanics of browsing the web. I mean, the next time you are checking out of a shopping cart and you are forced to hesitate over a checkbox, or you just breeze through a login screen without any friction at all, you are navigating the front lines of an incredibly sophisticated, invisible verification system.
You really are.
You aren't just clicking a button. Your kinetic data, your hardware footprint, and your behavioral history are being rapidly calculated to verify your humanity.
You are participating in a continuous, microscopic behavioral audit.
It's wild to think about, but it leaves us with an incredibly provocative technical question to end on today, building on the trajectory of the machine learning we've discussed.
Okay, what's that?
If the entirely passive, invisible future of CAPTCHA relies on analyzing human imperfection, the microtremors in our mouse movements, the slight hesitation before a click, the biological noise of our kinematics, what happens when the bot developers adapt to that?
That's the million-dollar question.
What happens when malicious engineers begin using reinforcement learning to train their scripts to intentionally mimic that exact biological noise? When a neural network is explicitly trained to simulate the erratic, hesitant cursor trajectory of a tired human trying to buy concert tickets, how will the security algorithms ever mathematically differentiate between a biological organism and a machine that has been flawlessly optimized to be imperfect?